Hello and welcome. Today we're going to start off with chapter 9.1, and before we get started we're going to get some vocab out of the way. The first vocab that we're going to talk about is variable. Now, variable, there's a lot of different definitions out there. The one that we're going to talk about is where it's a letter that represents a changing number. Now, you're probably thinking, okay, what do you mean by a changing number? That's a good question. So, something that doesn't stay the same. For example, let's say I let t, and this is an example, not always so. T equals time. Time is continuously changing. You probably just lost a couple of seconds of your life and you're not going to get them back no matter what you do. And it keeps on ticking away. So you're losing second by second as I keep on rambling to you. That's what I mean by a changing number. It doesn't stay the same. It's changing always. When it doesn't change, that's what we call a constant. Now, we can also use a letter to represent constants. Not always do we use letters to represent constants, but we have in the past. And a letter represents a constant, a number that doesn't change. Now, instead of doesn't change, I'm going to use a phrase where we say it's set in stone. So something that does not change, it's a constant. Let's see, what's a good example of that? Probably if we wanted to describe that, we could say Y, where Y is the year you were born. No matter what you do, you can't change the year you were born. If you were born in the 80s, you're stuck. You were born in the 80s. You can't change that. So that's set in stone. It's a constant. Now, with that in mind, we're going to tackle problems. And our first objective that we're going to learn in this section is to evaluate an algebraic expression by substitution. This word substitution basically is our fancy talk. Oops, let me fix that. Is our fancy talk for plug and chug. Now, what I mean by that is they're going to tell us a long-winded bit of information. You can already be looking at this and going, oh, it's a word problem, but it's really not too bad. They're saying the area of a triangle with base B and height h is given by this formula. Area equals 1/2 base times height. Find the area when B is a set value and h is a set value. Now, what we're concerned with here is just plugging in the values they told us to. We know B is 25 meters, and it's really not all that important to us about the units just yet. Then they also tell us height is 32. So what we're going to have to do is take that formula where area equals, and that's what they want us to find, 1/2, that's a constant, can't do anything about it, times the base times the height. And we just got to plug in the information. Base was 25 and the height was 32. Now, going on here is multiplication. We don't usually write the little dots, oh dear, but that is what's going on between each of the variables when they're in that formula, implied multiplication. So we can multiply in any order we please because of commutative law. Now, I'm getting a little bit ahead of myself here, but I just want to let you know this, all right? So let's keep this in our mind, and we'll put a little bubble around it. 1 times 2 is 2. And 2 times 1 is also 2. And 2 equals 2. So if you notice, we can switch the order of multiplication here, and it doesn't change the result. It's still the same answer. So keeping this in mind, we can multiply in any order we want here. We could take 1/2 times 32 times 25 if you wanted to switch it around a little bit, just because this is an even number. That's the only reason why I wanted to switch things around. And it's easier for my brain to see, oh, 2 could go into 32 16 times, And now all I have to do is 16 times 25. And I don't know about you, but I can't do that in my head, so I'm going to have to go off to the side and write it out. And let's see. 6 times 5 is 30, carry the 3. 6 times 2 is 12, plus the 3 is 15. Placeholder, don't forget it. And sorry, my work's getting a little squish because I'm running out of screen. 1 times 5 and 1 times 2. Add them up. And we end up with 400. Now, those units, I told you to forget about them, but let's come back to them. Whenever we talk about area, area always has our unit, whatever it may be, squared. And you always talk about like the area in a house. You say it's how many square feet, or maybe square meters if you're European. So our unit here is meters squared. And there's our answer. The next one is the same exact question, just a different formula and different numbers to plug and chug. So it says the front of a rectangular goal for a professional sport, a lot of useless information, is 10 feet wide and 5 feet high. Find its area. Now, we have a rectangle, so it is assumed, I know it's always a bad thing, that we know the formula for the area of a rectangle. And the area of a rectangle equals length times width. They provided the length for us, and they provided the width for us, and all we have to do is multiply the two together, and our unit is always squared. So once more, we just had to plug and chug. A little bit of extra work because we had to know this formula, though. Let's do another one where maybe it's not such a wordy problem. It's more direct and to the point. We have evaluate. This word is the fancy talk for substitute, or the fancy talk for plug and chug. And it says the expression when y equals 3. So we have 8y. What's going on there is 8 times y. Once more, we didn't write that multiplication, but that's really going on between the two. And y here is really 3. So instead of y, we're going to plug in 3. So we have 8 times 3. And 8 times 3 is 24. Fairly nice. Let's see if they can get worse. And they're trying. They really are, but it's not going to happen. All we have to do is know evaluates the fancy talk for plug and chug. And we have z over y. So we'll plug in what z equals into the expression over what y equals. And then we just got to simplify as much as possible. Let's see, can 6 go into 72? Yep, and it goes in there 12 times. So that's it for objective A. The next objective that we have is B, in which we're going to translate phrases to algebraic expressions. Here we have addition, subtraction, multiplication, and division. And there's just some keywords out there that represent what each operation can mean in words. Now, probably the nicest one is division, because you notice they have 1, 2, 3 of them, and that's it. And they're very nice words. Division can be divide, divided by, and quotient. Multiplication is also very nice too. Multiply, multiply by, product, times, and of. Of is the big one to keep track of, and I'm going to pause. Now, subtraction doesn't have too many troubles. All the words generally mean exactly how we'd interpret them. The only one that gives us a little bit trouble is less than, and we'll see an example shortly of him. And then addition is also very nice. What you do want to make note of is to remember the special names. There's sum, difference, product, and quotient. Mathematicians like to use it because it's kind of our fancy way to say adding, subtracting, multiplying, dividing. So I want to hang on to those. Let's go ahead and see an example. So the directions ask us to translate to an algebraic expression. And it says we have 48 more than Q. More than was one of the words that translates to addition. So we could write we have 48 more than Q. Now, technically, this is correct. There's just a better way to write it. We usually like to see the variables first and the constants last. And we'll talk more about this in chapter 12 when we talk about descending order. So when we translate, it says 48 more than Q. Well, we could take whatever Q is, add 48 to it, and there is, that was ugly, our solution. Now the next one is the one I kind of warned us about. It uses the word less than. We're saying we have 2 less than B. And let's pretend we're in an alternate universe where I said I have $10 and I went and spent $2, so I have 2 less than what I started with. Well, I said I started with 10 and then I have 2 less than that, so I end up with 8. I took what I started with and then subtract out the 2. That's the same deal over here. We're saying we have 2 less than B, so we're starting with B and we have 2 less than whatever B is. So it almost kind of reads backwards to some students. And this is the only way to write our answer. Because if we were to try to switch things around, let's go back to our example with the 10 minus 2, right? If I said I had 2 and then I went and spent 10, that's completely different. I end up where I'm in the hole, $8. And that's negative. You can't switch the order for subtraction. It is not cumulative. And then last but not least, we have 4 more than 4 times a number. Now, they just said a number. So what number? We don't really know, but we can make it anything we want it to be. Let's say n for number. I'm going to call that. So I have 4 more than 4 times a number. Well, I have 4 times a number and then 4 more. And there's our answer. And that is pretty much it for chapter 9. So I'll see you guys again for chapter 9.2, and make sure you work on your homework.